in general chemistry, you will need to do some quantitative problems. The first step in getting the correct answer to these problems is to know how to do the algebra. Let's do a couple problems, and through these we'll focus on dimensional analysis and significant figures. Let's start with a simple question. How much does a 150-pound Chemistry 106 student weigh in kilograms? This is really just the conversion of units problem. We need to convert from pounds to kilograms. So let's start. Whenever we want to use dimensional analysis, we need to start by writing down something that we know. And we know that we have 106. Actually, that is what we call extraneous information. It really doesn't matter that this is a Chemistry 106 student. What matters is that they weigh 150 pounds. Any 150-pound object would give the same answer. So 150 pounds, to convert that to kilograms, we just multiply by a conversion factor that will have kilograms in the numerator and pounds in the denominator. So we need to know how many kilograms in a pound. You might not know that. So look it up in the back of your textbook, and you'll find out that the textbook does not tell you how many kilograms in a pound, but it does tell you how many pounds in a kilogram, and that's just as good. So we can say 1 kilogram is equal to 2.2046 pounds. And note that the numerator and the denominator are equal, therefore this ratio is equal to 1, true for all conversion factors. And so what we're doing is we're multiplying by 1. We're not changing the quantity, we're only changing the units. But the pounds in the numerator and in the denominator will cancel, leaving us with units of kilograms. And we just have to do the calculation. So 150 divided by 2.2046 equals 68.0396. So there's our answer. But what about significant figures? We've got 1, 2, 3, 4, 5, 6 significant figures I wrote down, but the number that we started with really has only 2. We'll presume that that 0 is not significant. So we need to round our 68.0396 to 2 significant figures, which would be 68 kilograms. And there is our answer. Now, whenever we do a problem, it's always good to make sure that the answer is reasonable. So, is that reasonable? Well, we know, roughly speaking, that there's 2 pounds per kilogram, and that you might have known already. But in any case, 150 pounds, since kilograms are bigger than pounds, we don't need as many kilograms, so we're going to be dividing by 2, 75. It's a little more than 2, so dividing by a little more than 2 is going to give us a little less than 75, and 68 certainly fits that. So that makes sense. Let's look at another problem, a little more involved. How many miles can a bicyclist go in 90 minutes traveling at an average speed of 10 meters per second? This is not just conversion of units, because we're asked how many miles, but we're not given any other distance. The only distance we're given is 10 meters per second. That's a speed. And we're given time, so we have to do a calculation and unit conversion. Before we do that, though, let's ask this question. What are these decimal points here for? What those are there for is they're showing us that these zeros are significant. So each of these is a 2 significant figure number. So unlike the 0 and the 150 in the last problem, these zeros are significant. That's important for once we get our answer. So let's start. We want miles. here's the distance we have, 10 meters per second, so let's start with that, 10 meters per second. And we can start with either the numerator or the denominator. Denominator is probably simpler, so let's do that. So we need to convert seconds into minutes so that we can use this number, 90 minutes. And so we need a conversion factor that has seconds in the numerator and minutes in the denominator. And you might know how many seconds are in a minute, 60. And seconds will cancel. And now we can multiply by 90 minutes. And minutes in the denominator and numerator cancel. And now this calculation gives us a distance in meters. We need the distance in miles, so all we have to do now is convert meters to miles. So we need another conversion factor that has miles in the numerator and meters in the denominator. So we look that up in the back of the textbook, and we find that that conversion factor is not there. That is, it doesn't tell us how many meters in a mile. It does, though, tell us how many kilometers in a mile. So we write that down. So we have in 1 mile 1.6093 kilometers. So we're closer. Now we just need to convert kilometers to meters, and you probably know that's a factor of 1,000. But let me show you a different way of doing that. I mean, what you would probably do, what you're probably used to, is doing another conversion factor, and that would be saying 1 kilometer over 1,000 miles. But it's simpler to just say k is equal to 1,000. So let's just cross off the k and replace it, substitute with 10 to the 3. And so now we're ready to do our calculation because the m cancels, numerator and denominator, and all units are gone except for miles, so our answer will come out in miles. Let's do the calculation. So we have 10 times 60 times 90 divided by 1.6093 divided by 1,000, because 10 to the 3 is 1,000. And that gives our answer to be 33.555 in 5 significant figures. How many significant figures should we have? Well, each of these had 2, so we need to round that to 2 significant figures, and that would be 34 miles. And that's our answer. Is that reasonable? Well, let's look at it this way. 10 meters per second, we can try and evaluate that and see what that is in units we know, but let's just say this way. How fast does a bicyclist typically go? Well, if a bicyclist is moving relatively fast, it's probably around 20 miles per hour. 20 miles per hour in an hour and a half, that person would go 30 miles. And look what we got, 34. So that's a pretty reasonable number for how far a bicyclist could go in an hour and a half. One more thing I want to point out is that we have made an assumption here, because this says the 10 meters per second is an average speed. So we are assuming that over that 90 minutes, that average speed is correct. The bicyclists may be going faster and slower, but on average, they'll be going that fast. It's probably a pretty good assumption that 90 minutes is a pretty long time. That average speed is probably pretty accurate. So that is what leads us to our answer. And there's a couple examples of using dimensional analysis and significant figures.